Hello everyone, my name is Reza and I'm a developer advocate at Tigera. Today I'm going to talk about how Calico eBPF can turbocharge a Kubernetes cluster. This presentation has 4 sections. First, I'm going to talk about the community behind the project Calico and what Calico offers for a cloud environment. Then I'm going to focus on our eBPF-based solution to give you a better idea of why eBPF can perform better in many scenarios. After that, I'm going to talk about XDP and how you can use it to defend against DOS attacks and gain even more performance out of your Kubernetes cluster. Finally, I'm going to show you a demo where I use Calico to bypass Linux contract. If you're new to cloud networking or just starting your journey, don't worry, I got you covered. At the end of this presentation, there is a QR code link that gives you a hands-on lab environment with step-by-step instructions to test out everything that I'm going to show you in this presentation. Alright, let's start by an overview of our community and a brief insight of our Dataplane offerings. Our community has grown a lot throughout the years, and we have came a long way since we started Project Calico. Today, we have more than 300 code contributors who participated in the future of Project Calico. From the beginning, we designed Calico to be flexible and extendable. We relied heavily on Linux kernel, and our standard Linux Dataplane and policy engine has been widely adopted by cloud providers and cloud users all around the world. Today, Calico offers 4 data planes that can be switched on depending on your needs and environment. In fact, these data planes are the foundation of our enterprise offerings at Tigera, and a lot of companies rely on Tigera's support and solution to provide security, observability, and networking for their cloud environments. Calico standard Linux Dataplane can work with either IP tables or IPVS to control traffic in and out of your cluster. It can run on multiple platforms such as x86, ARM64, and others. It is also compatible with Linux with kernel as low as 3.10 or later. It is also compatible with most distros such as Red Hat Linux, CentOS, CentOS Container Linux, Ubuntu, and Debian. Calico's eBPF Dataplane is a free and open source networking solution for the cloud that offers 3 key benefits: performance, native Kubernetes service handling, and finally source IP preservation. In terms of performance, without eBPF, packets use the standard Linux networking path to reach their destination. eBPF Dataplane, on the other hand, leverages the power of eBPF technology to interact with packets as early as possible and ushers them to their destination by implementing its own routing mechanisms. We will go through the details of this process in the later slides. It is worth noting that Calico's eBPF Dataplane allows containers to bypass the complex routing puzzles that are implemented in the kernel after each container creation. In eBPF mode, Calico also converts the policies to eBPF programs and attaches them to the individual interfaces, which allows you to get better performance and resource utilization in any eBPF-enabled cluster. VPP is another supported data plane for Calico. Currently, VPP is in its beta stage, but it is worth the attention since it poses a very unique advantage. VPP is entirely compatible with other Calico data planes, meaning you can have a cluster with VPP-enabled nodes along with other data planes. In addition, the VPP Dataplane offers some specific features for network-intensive applications, such as providing packet interfaces to the pods, or exposing the VPP host stack to run optimized layer 4 or higher applications in the pods. But in my opinion, I think the most important feature that I tested out is the performance boost that it grants to encrypted traffic inside a cluster. Clusters that run technologies such as WireGuard and IPsec can be a real example of where VPP could play a major role. Now let's switch realms and talk about Windows. Calico for Windows provides a familiar way to establish security for your hybrid cluster. Calico for Windows is the official Microsoft Azure Kubernetes plugin to establish security for a hybrid environment. On top of these, Calico offers features such as IP management, easy installation, BGP mesh, VXLAN overlay, and many more for these type of environments. As you may have noticed, eBPF is also gaining popularity in the Windows community, and that is why Tigera is committed to bring its eBPF solution to Windows. Now that we have a better understanding about Calico data planes, we can focus on eBPF data plane. But before comparing eBPF to other data planes, let's explore this image to understand why Calico's eBPF data plane can have a better performance over the standard data plane. In a cluster that uses the standard Linux data plane, this is how kubeproxy allows the information to flow. The external client, here shown at the top of this diagram, represents a user outside of the cluster. And at the bottom of this diagram, you can see two Kubernetes cluster nodes. When the external user sends a request to the cluster, in a step 1, kubeproxy, shown here in orange, applies destination and source NAT to the traffic that it receives. Destination NAT is necessary to ensure the traffic gets to the pod that has been chosen to service the user's request. SNAT is necessary to ensure that the traffic is passed back through the ingress node so that it can keep track of the flow using the contract table. Since the load balance request arrived at the node that doesn't host the intended workload, we have to send the request to the other node. This is why in a step 2, the packet is forwarded between the nodes to be received by the intended service pod. In a step 3, the pod processes the request and sends a response back to the kubeproxy on the ingress node that initially received the traffic and has the NAT informations. In a step 4, SNAT and DNAT are reversed, and reply can finally go back to the client. In this setup, because kubeproxy applies a source NAT to the initial traffic and changes the source IP of the packet to its own, the service pod never sees the true IP of the user. That means that the service pod is not able to make any kind of intelligent decisions, such as applying quality of service or denying service based on the ingress IP, which could also be a potential problem for security too, because the audit logs on the service pod will not record the detail necessary to know where the request originated from. Now that we have a better understanding of the standard data plane, let's look at the Calico's eBPF data plane and see how it can replace the kubeproxy and achieve a better performance. Same as before, the external client is located at the top of this diagram, and Kubernetes cluster nodes are at the bottom. The only difference here is that this cluster utilizes the power of Calico's eBPF data plane for networking and security. The external client connects to a service load balanced to one of the cluster nodes. This time, in step 1, the eBPF program shown in orange forwards the packet instead of NATing it to the node hosting the service pod. In step 2, only a destination NAT occurs, to make sure that the traffic gets to the service pod. In step 3, since pod can access the real IP address of the requester, it can make all kind of intelligent service or security decisions that we couldn't do in a standard Dataplane setup. In step 4, the service pod responds and the DNAT is reversed on the same cluster node as the service pod. Finally, eBPF sends back the response to user by using the direct service return feature of eBPF Dataplane. Hopefully, you spotted the 2 improvements that the eBPF Dataplane offers here. First, source IP preservation. The service pod can see the real IP address of the user because it doesn't do a source NAT. Second, direct service return, or DSR, can provide a reduced latency by directly sending the packet back to its requester. On top of that, it is worth mentioning that kubeproxy's implementation uses a list of rules that grows with the number of services that you create in your cluster. And that's why its latency gets worse as the number of services increases. IPVS mode and our implementation of eBPF use an efficient map lookup instead, resulting in a flat performance curve as the number of services increases. By the way, as you can see on the chart, Calico eBPF Dataplane is slightly faster than IPVS. Calico also offers XDP acceleration for both dataplanes that can be used to gain more performance out of your Kubernetes cluster. Similar to eBPF, XDP allows you to interact with networking packets as early as possible. There are 4 types of XDP programs that can be used in an environment. The fastest, which requires a special networking card, is called XDP offload. Next in line, in terms of performance, is XDP native, which happens at the network card driver level. XDP generic mode and IP tables raw are 2 remaining ones that can be used in Linux regardless of your hardware equipment and can achieve a similar performance. Felix, the brain of Calico, automatically determines which method is available in your system and can be tuned by policies to manipulate traffic by using XDP programs. Calico utilizes the power of XDP to provide DOS protection and handling extreme high connection workloads. During a DOS attack, a cluster can receive massive numbers of connection requests from attackers. The faster these connection requests are dropped, the less floating and overloading these can cause to your hosts. When you define DOS mitigation rules in Calico network policy, Calico enforces these rules as efficiently as possible to minimize the impact. Here is all you need to do in order to defend yourself against a DOS attack with Calico. First, you need to create a host endpoint resource as the policy enforcement point for your cluster. Then, you need to create a global network set to manage the denial listed CIDRs. These are all the IPs that are trying to attack your cluster or infrastructure. And a global security policy resource to deny ingress traffic from IPs in the global network set that we just created. This security policy resource requires 2 unique values that you usually don't use. Apply and forward and do not track must be enabled in this global security policy. After creating these resources, Calico can drop every traffic associated with the global network set as efficiently as possible, either inside your NIC or inside the kernel. By the way, if you would like to learn more about XDP and DOS protection, make sure to check out this QR code, which gives you a step-by-step tutorial on how to configure a DOS protection on your own cluster. You can also use Calico and XDP to boost the number of requests that your cluster can handle. Normally, when requests come into your server, it will go into the kernel, and a record of its origin and destination is stored in the kernel so that the Linux kernel knows how to reach the sender. You can change this default behavior by creating a host endpoint for your node network adapters and associating them to a global security policy that permits the server traffic with apply forward and do not track values, which can boost the number of these connections by bypassing the contract, which can result in better resource utilization of such traffics. If you'd like to know more about this feature, you can scan this QR code where it talks about our motivations behind this feature and the results that our community got after applying this method to their clusters. All right, if you're ready, let's see eBPF and XDP in action. In this demo, I'm going to show how XDP can help a high connection workload like Redis. First, let's check out the Kubernetes cluster configuration. Great, I've got a cluster with 2 nodes. I'm going to use node 1 as the Redis server and node 2 for the client benchmark utility. Next, I'm going to check which Dataplane is currently configured for my Calico installation. Seems like I'm running the standard Linux data table. Turning on eBPF is pretty simple. All I need to do is to change the Linux data plane to BPF in the installation custom resource definition that I just queried. To verify the change, I can issue the same get installation command that I executed earlier. However, this command doesn't give me a lot of outputs. In order to get more information about BPF, I could look into the logs that Calico node pods are outputting. Let's do that. Great, seems like eBPF is enabled and everything is working. Next, I'm going to use a deployment to deploy a Redis server into my cluster. I've added a node selector to ensure that my Redis server always runs on node 2, which can help me with a lot of configurations later on. I'm also using host network in order to open up a socket directly inside my host. Great, everything is set up. And now is the best time to run a benchmark in order to get a point of reference on how system behaves when contract is actually enabled. For this benchmark, I'm going to use the Redis benchmark utility, which is usually available when you install Redis. I'm going to instruct the pod to be installed on the other node, node 1, and connect to my node 2, which hosts the Redis server, and create 1,000 connections. I'm also going to use the power of editing in order to fast forward here and save some time. Alright, now that the benchmark completed, let's go to Prometheus and check out how many contracts are actually recorded into the system. Seems like Prometheus recorded 60,000 connections during this benchmark. Now that the benchmark completed and we have all the data inside Prometheus, let's go ahead and flush all the records that are currently inside the contract table. If you recall, During my presentation, I talked about host endpoint security resources and how they can allow Calico to apply security policies to the host network cards. A host endpoint resource represents one or more real or virtual interfaces that are attached to a host that is running Calico. It enforces Calico policy on the traffic that is entering or leaving the host's default network namespace through those interfaces. A host endpoint is a unique Calico security resource registered under the Project Calico.org API group. And there are a couple of important values that require more attention when you decide to create one. For example, labels are how you can reference the host endpoint inside other policies. Interface name will instruct Felix, the brain of Calico, to know that this host endpoint must be applied to which host interface. Node must match your node names and expected IPs, which is crucial in order to help Calico in resolving labels that are associated with an endpoint must point to the IP addresses that are used by that interface. Similar to security policies, in the absence of host endpoints, all traffics are permitted from that interface. But when you create a host endpoint resource, this behavior will change to deny everything and only allow what explicitly has been permitted. So next, I'm going to create a global security policy that permits essential traffics, such as incoming ICMP or ping, kubectl execute and logs, and outgoing etcd database port, and services such as DNS and DHCP to flow. On top of this, Calico has a configurable failsafe that is enabled by default to make sure that a misconfigured host endpoint policy cannot disrupt the flow of traffic for these essential ports and make your cluster unreachable. I'm also going to use the host endpoint labels that I created earlier in this policy as a general selector to associate the two resources together. This will make sure that my new policy will only affect traffics that are incoming or outgoing from that specific interface, which is tied to the host endpoint. Next, I'm going to create another Calico Global Security resource to permit communication between my clients and Redis server. Note that in this policy, I've used the apply and forward and do not track values. If apply and forward is true, the host endpoint policy applies to forwarded traffic that comes in via host endpoint and is forwarded to a local workload, things like containers, pod, VMs, traffic from a local workload that is forwarded out via a host endpoint, and traffic that comes in via host endpoint and is forwarded out via another host endpoint. If you take a closer look at this policy, you can also see that I've created both ingress and egress rules for my Redis workload. Since I'm disabling contract by using the do not track value in my policy, if I write a single ingress rule without a proper egress, the packet will reach my cluster. However, since Linux has no records of that traffic origin in its contract table, it cannot send it back to its point of origin. Alright, everything is set. Now we can run another benchmark to see what changes when contract is disabled. Similar to the previous benchmark, I'm going to create a pod that has the Redis benchmark utility and instruct it to connect to the node 2 and make 1,000 connections to the Redis server. Excellent. Benchmark is completed. Now let's head to Prometheus and check our contract records. As you can see, while our client host is making more than 50,000 contract entries, our Redis host is stuck at 242, which I would assume are for other processes that are running inside the host. Now, keep in mind that in this demo, I've only focused on number of contract entries because it's quicker to measure XDP's effect on them. But using XDP has other benefits, such as better resource utilization and blazing fast networking decisions. In fact, if you have an application that can handle a lot of requests, but it's held back by kernel contract limitations, you can scale it by implementing Calico and using its eBPF and XDP capabilities. Other than scaling high connection workloads, another use case for Calico and XDP is DOS protection. Since XDP can handle massive number of requests very efficiently, you can use it to drop malicious connections rapidly and only allow good traffic to hit your backends. Alright, that's the demo. As promised, you can scan this QR code to access the hands-on lab environment that allows you to experience Calico's eBPF Dataplane and XDP. You will be able to read a step-by-step tutorial and see everything in a live environment. So that's the end of my presentation. I hope you have enjoyed it, and I'd like to thank you for viewing.